Hello everyone. In this video, we will be comparing slopes. Before we go over these two examples right here, let's compare slopes using Desmos. So I've set up the slope-intercept form of a line of the form y equals mx plus b. Now notice this, if the slope m is 0, the line is a horizontal line. Now what's going to happen if I increase the value of the slope? So if I increase the value of the slope right here, notice that the line is getting up. Then it becomes steeper and steeper. The more I increase the value of the slope, the steeper the line becomes. So if I increase this some more to 5, to 6, to 7, to 8, up to 9, all the way to 10, then so the line is closest to being vertical. Now, if I reduce the slope, if I decrease the slope, the line is now closest to being horizontal. Now, please remember that the steeper the line is, the greater or larger is the absolute value of the slope, which means that if a line is closest to being vertical, then the absolute value of the slope is greatest or largest. On the other hand, if the line is closest to being a horizontal, then the absolute value of the slope is smallest. Okay, let's go back to these two examples right here. Let's start with the first one. So in this problem right here, we are supposed to determine which of these lines, A, B, or C, has the greatest slope. We remember that the steeper the line is, the greater or larger is the absolute value of the slope. This means that if a line is closest to being vertical, then the absolute value of the slope is greatest or largest. On the other hand, if a line is closest to being horizontal, then the absolute value of the slope is smallest. So just by looking at this lines right here, we can tell that letters or line C is closest to being vertical, while line A is closest to being a horizontal. Therefore, we can go ahead and say that A has the least or the smallest slope, while C has the greatest or the largest slope. So we can go ahead and write the answer for this as line C. We remember that the formula for slope, represented as letter M, has a formula rise over run. Rise means we go up, and if we say run, it means that we go to either left or right. If we go to the left, we take the negative value. If we go to the right, we take the positive value. So we go ahead and write the formula for the slope up here. Okay, now we are going to determine the slope of line A first. So I'm just going to go ahead and write M of A. This means that's the slope of line A. Again, the formula is rise over run. So we are going to look for lattice points. So we start from this is our first lattice point right here. Then we trace line A to look for the second lattice point, which is located right here. So that we can go ahead and say that the slope would be, remember, it's going to be up and over, or we go rise over run. So we go one time. So we go up 1. And so that's 1 right here. And so we go to the right, 1, 2, 3, 4. So we went 4. So then we go ahead and say that the slope for A is 1. We went 1 up. 1 over 4. So pretty much 1 over 4. If we change this to decimal, this would come out 0.25. Okay, now let's determine the slope of line B. So I'm just going to go ahead and label this as MB, which means this is the slope of line B. So then again, it's pretty much the same thing. We are going to look for lattice points. So this is the first lattice point right here on the point of origin. Then we trace the graph. The lattice point, the second lattice point is located right here. So then we can go ahead and count how many steps do we go up or rise and how many steps do we go to the right. So that would be 1, 2, 3. So we went up 3. And so we go to the right, 1, 2. So we went to the right 2. So then the slope is rise over run. So that would be 3 over 2. And if we change this to decimal, this would be 1.5. Okay, now let's determine the slope of line C. So I'm just going to go ahead and write this as MC. That is, slope of line C is equal to, again, which is pretty much the same thing. This is our first lattice point. Then we trace the graph. This is our second lattice point. So we go ahead and rise. So we go up 1, 2, 3, 4. So we went up 4 over 1. So that is gonna be rise over run. So again, rise over run. So that would be 4 over 1. If we divide 4 divided by 1, that is actually 4. Okay, from here we can already compare the slope of the three lines A, B, and C. The one with the greatest slope or the biggest slope is line C because the value was 4. And the one that has the least or the smallest slope is line A, which is 0.25. Again, it matches up with the general rule that the steeper the line is, the greater or larger is the absolute value of the slope, which means that if a line is closest to being vertical, then the absolute value of the slope is greatest or largest. And if a line is closest to being horizontal, then the absolute value of the slope is smallest. Now let's move on to the next example right here. Okay, in this example, the y-intercept is not actually on 0, 0 or point of origin, but the general rules still apply. So let's go over this problem here. So we are supposed to arrange these lines right here in descending order. Please remember that descending means from largest to smallest slope. So we go over this problem right here. Just by looking at these three lines, line A, line B, and line C, we can tell that the line that is closest to being vertical is line A, and the line that is closest to being horizontal is line B. We can therefore say that our line A is the one that has the biggest slope, while our line B is the one that has the smallest slope. So that we can go ahead and write our answer right here. If we say, again, descending, that's from largest to smallest, we can say that our largest line with the largest slope is line A. And the line that has the smallest slope is line B. So therefore, C is in between these two. Again, we got these answers based on the idea that the steeper the line is, the greater or larger is the absolute value of the slope, which means that if a line is closest to being vertical, then the absolute value of the slope is greatest or largest. On the other hand, if a line is closest to being horizontal, then the absolute value of the line is smallest. So using that idea right there, we can just go ahead and arrange them. But let's show this answer that we have here quantitatively. Now we remember that the formula for slope, which is represented as letter M, is rise over run. When we say rise, this means that we go up. And when we say run, this means that we go either to the left or to the right. If we go to the left, we take the negative value. And if we go to the right, we take the value as positive. So then we can go ahead and write the formula for the slope here. Okay, so let's determine first the slope of line A. So I'm gonna label this as M of A, which means that is the slope of line A. So we're going to look for lattice points here. So we start from here. That's the first lattice point for line A. Then we trace the line and then it goes all the way here. So that is the second lattice point, so that we can go ahead and determine how many times do we go up or do we rise and do we run to the right. So that would be 1, 2, 3, 4, 5, 6, 7. So we went up 7 over 1, 2. So that is 2 right there. So we can go ahead and say that our slope is 7 over 2. We rise up 7 and we run 2. So 7 divided by 2 is 3.5. So let's determine the slope of line B. So again, we are going to write this as M sub B. That means that's the slope of line B. So that we go ahead and determine the lattice points. That's the first lattice point for line B. And then we trace the graph. The second lattice point is located up here. So this is the second lattice point. So we're going to go rise over run. So we count 1, 2. So we went up 2. And then we go to the right 1, 2, 3, 4, 5. So we went to the right 5. So then we can go ahead and write the slope for this as 2. That is rise over run. So that is 2 over 5. If we change this to decimal, this would come out 0.4. Okay, let's determine the slope of line C. So I'm going to label this as MC. That means that's the slope of line C. So it's pretty much the same thing. We start from the point of origin. That's our first lattice point. We trace the graph and it goes all the way right here. So this is the second lattice point. So we go up 1, 2. We rise. That's 2. And then we go to the right. That would be 1, 2, 3. So then we can go ahead and say that the slope for this is rise over run. So that would be 2 divided by 3. So if we use the calculator, 2 divided by 3 can be rounded off to 0.67. So then from here, we can go ahead and say that line A is the one that has the biggest slope, while line B is the one that has the smallest slope, which matches to the answer that we have here, using the idea that the steeper the line is, the greater or larger is the absolute value of the slope, which means that if a line is closest to being vertical, then the absolute value of the slope is biggest or largest. Now, if the line is closest to being horizontal, then the absolute value of the slope is smallest. So it's either you want to show it quantitatively, like solving for the slope, or we use that idea of being closest to being vertical or being closest to being horizontal, then the answers would still be the same. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!